There are many stars in space, each roughly as luminous as the sun. And in an endless everlasting cosmos, no matter which direction you choose, you would see a star or galaxy if you looked far enough in that direction. As a result, the entire sky should be as bright as the sun, both at night and during the day. And, if it isn't, does the darkness of the night sky imply that stars and galaxies have stopped moving away from us? Is there a line between something and nothing? Is there an edge to the universe? Not quite. All of our evidence suggests that space has no edges, but the cosmos does, albeit a temporal one rather than a spatial one. According to what we know, the cosmos had a beginning, or at least a point around 13.7 billion years ago when the universe was so little and crumpled up with itself that our usual notions of space and time broke down. And, because just a finite amount of time has gone since this so-called beginning, some of the stars required to fill up the brightness in all directions are so far away that light from them simply hasn't had time to reach us yet. It's as if the cosmos were a massive rainstorm and we're still waiting to hear thunder from the farthest stars. Because light takes time to travel throughout the cosmos, when we look through a telescope at anything very far away, we are actually viewing that area of the universe as it was when the light was emitted. So, when we look at 13.5 billion year old light, we don't see stars because their light hasn't yet reached us. We don't see any stars because we're seeing the universe before stars originated, a starless cosmos. It's true, we can identify points in the sky where there are no stars by looking past the first stars and hence further back in time. But even when we look past the first stars, we find light, not starlight, but light left over from the Big Bang. This cosmic background radiation is detected as coming from all directions, forming a background beyond the stars. So the night sky is not all that dark to begin with. Right, so if our telescopes show that the night sky isn't dark, why does it appear dark? Here's a hint to the correct answer. The Hubble telescope used an infrared camera to photograph the distant stars of the breathtakingly stunning Hubble Extreme Deep Field. Why? Because the universe is expanding, so the stars and galaxies are moving away from us. So, much the same as slowing down a record lowers the pitch of your voice, the Doppler effect causes stars traveling away from us to grow redder. And as they get further away from us, they turn redder and redder until they reach infrared. Then we can no longer see them, at least not with our human sight. As a result, the night sky appears dark. In conclusion, if we lived in a limitless, unchanging universe, the entire sky would shine as brightly as the sun. But the sky is dark at night for two reasons. First, the cosmos had a beginning. Therefore, there aren't stars in every direction. And second, the light from super distant stars and even more distant cosmic background radiation is redshifted away from the visible spectrum as the world expands, so we simply cannot see it. That was all for now. If you want more videos like this, please like, subscribe, and leave us a comment for more topics.